show that x minus 1 is a factor of x cubed plus x squared minus x minus 1. So it's like 1 mark, right? So what you can do is to let fx be equal to this function over here. So that if x minus 1 is a factor of this, that means you can use x equals to 1. That means f1. And show that this is 0. So 1 plus 1 minus 1 minus 1 equals to 0. This is by factor theorem. So hence, x minus 1 is a factor of fx shown. Okay, so using fx to represent the equation also has the benefit of writing your conclusion as fx. Makes it a little bit faster. Part 2, express this equation here as the sum of 3 partial fractions. So this is a hint that you actually have 3 different factors over here, right? So knowing that x minus 1 is a factor of this equation over here, you can actually do a long division. Divide this by x minus 1. Remember that we have to systematically get rid of the first term one by one, all right? So we get rid of x cubed first, and we produce an x squared over here. Okay, minus, bracket, draw a line. So the first term is gone as what we intended. This is now 2x squared minus x minus 1. Then we get rid of the first term in this next line, which is 2x squared, and we produce 2x. Right? Then minus and draw a line. Sorry, this should be positive 2x to get a positive 2x squared. So this should be a negative. Yeah, there we go. All right, so this is now a positive x minus 1. So plus 1 and x minus 1 gives you a remainder of 0. So this is also one of the things you need to check for, if you recall. Because you know the x minus 1 is a factor, so of course you have 0 remainder. So if for some reason your remainder is not 0, that means you made a careless mistake somewhere. So pause there, go back and check before you proceed. Okay, so hence you can actually express fx as x minus 1 times x squared plus 2x plus 1, your quotient. So because you need to express as 3 partial fractions, you need to produce 3 different factors over here. So that means you need to further factorize this quadratic equation. All right, so this is 1, 1, plus, and plus. So actually this can also be written as x plus 1 square. Okay, so now that you've factorized this successfully, then you can attempt to do your partial fractions. 4 over x cubed plus x squared minus x minus 1 is actually equal to 4 over x minus 1 and x plus 1 squared. This is repeated linear factors, because your x plus 1 is a factor that's repeated twice. That's why you square it. So the partial fractions that you need to form will be a over the first factor that's not repeated, b over the second factor, not repeated, and the third one is over the second factor but repeated. Okay, just take note over here, one common careless mistake is that for C, you might recall your quadratic factor and then you write cx plus d, but that's not the case for repeated linear factors, right? So hence, equate your numerators. 4 is equal to a, b, c multiplied by the respective denominator. So this one is also a point of a point where you want to take note, because you should imagine combining your right hand side 3 terms into one single fraction. So actually you should focus on the denominator. What more do you need in order to make your denominator same as the left hand side? Think of it that way. So for A, you already have x minus 1, so you only need x plus 1 square. For B, you have x plus 1, one of it. So you need 1 of x minus 1, another one of x plus 1. And for C, you already have x plus 1 square. So you only need x minus 1. Okay, so come to this point, we use cover-up rule. So we let x be equal to 1, let's say. So that anything that has x minus 1 will then be 0. On the left-hand side, we have 4. And on the right-hand side, B and C are going to be 0 because they have x minus 1. 1 minus 1 gets us 0. So we're only left with the A term. And this is 1 plus 1, so 2 squared. So this is like 4a, and hence a is equal to 1. Okay, then we let x be equal to -1 this time. Left hand side is still 4 because we don't have any x on the left hand side. On the right hand side, anything that's x plus 1 is going to be 0. So a and b are 0. And now this is c, and multiplied by -2. And so c is actually -2. All right? So last but not least, we have this b that we need to solve. So this one, you can choose one of two methods. If you want to stick to the basic fundamentals, then for this one, you need to use comparison of coefficients to look at your x squared coefficients or your constants. And the other way that you can use to do this, because you only have one unknown left, you can substitute any value of x that you like in order to solve for this last remaining unknown. So let's say I use the second method that I've mentioned just now. I let x be equal to 0. On my left hand side, this is 4. On my right hand side, I will have a, which is 1, multiplied by 0 plus 1, so that's 1 squared. That's my first term. Second term, it's b, multiplied by a -1 here and a +1. And last, I'll have my c, which is -2, multiplied by a -1 over here, 0 minus 1. Okay, so let's simplify the right-hand side here. This is 1 minus b plus 2. Okay, be very careful not to make careless mistakes. So if I bring my b over here, and I simplify my 1 and 2, that's 3, and then minus 4. The 4 is from the left-hand side. Okay, so this is -1. All right, so check back what's the requirement of the question. It says to express this as the sum of 3 partial fractions. So your final answer, they want to see 3 partial fractions. So you need to do a final substitution over there. So rewrite the question: 4 over x cubed plus x squared minus x minus 1 is equal to a. So that's 1 over x minus 1. Be sure to bring in your denominators exactly the way that you phrased them at the start, okay? And then b, so that's -1, so -1 over x plus 1. And c, which is -2, so -2 over x plus 1 squared. That's done.